For everyone to join today. I think it's a massive event. I think we have about 100 people just joined in the channel. I think today's topic is about scaling Kubernetes across BlackRock's Aladdin platform. And in high level, we have two agendas. The first agenda will be BlackRock will give us the deep overview about what they have done with Kubernetes. I think that journey will be fascinating to us for sure. And secondly, I think once we got the Daniel Magam join us, and he will also give us a project update about the Crossplane. The Crossplane is a rising open source product which help you to manage your infrastructure in the YAML and in the Kubernetes, using Kubernetes as a control plane to manage your whole cloud infrastructure. So thank you for joining me today. So I'm the host of the event today. So my name is Hong. I'm the founder and the CEO of the QTIO. I'm also the founding contributor for the Argo project. And we also have two speakers right now from BlackRock. Ryan Armstead is the software engineer with specialization in cloud technologies. He's leading the team to define the Kubernetes experience at BlackRock and turn the blueprint into reality. So let's welcome Ryan Armstead. Thank you.
Yeah. Welcome.
Then we also have the Mike Bowen, and he is the open source advocate, evangelist, and engineer as a part of the platform engineer team. He believes in the cloud native and open source. He's the main driver and the brain behind the Kubernetes adoption at BlackRock. Welcome, Mike.
Thank you.
Cool, yeah, without further ado, I think we have a great topic to learn the Kubernetes journey of a massive fintech company, BlackRock, and also plenty of time to have a conversation. So Ryan, you can take it over.
All right, let me share my screen here and we can get started. Thank you for the great introduction, and shout out to all the people at BlackRock who has helped make this possible. It's not just the Mike and Ryan show, it's everybody. So yeah, we are going to talk about scaling Kubernetes across BlackRock's Aladdin platform, and I'm going to hand it off to Mike to kick us off.
Awesome, Ryan. Thank you. Yeah, we absolutely subscribe to a mantra here at BlackRock. It's called One BlackRock. We don't take it mildly. It's not a cliche. We actually live it every day. It is innate to our culture here at BlackRock. And Ryan and I specifically, we work on the platform engineering team. We work on platform services that help enable our developers that provide business value to our clients. And as a large asset manager, we're fiduciary to our clients. So our number one customer are the people giving our number one customers as a firm the ability to make better investment decisions, and to do that as a fiduciary, and to do that at scale as one of the world's largest asset managers. So outside of BlackRock, it being awesome, and Ryan and I love working there, we do have a platform called Aladdin. And in this talk today, we're not just going to talk about Aladdin, but we'll talk about our cloud native journey to date, how we've embraced cloud native, and especially in the open source. Authors of a component of Argo, and so we are maybe unconsciously biased to our Argo friends and the folks that code fresh into it and Red Hat. So bravo to all you folks if you've joined or otherwise and you hear this on the recording. Argo is how you solve complex cloud native problems, whether it's workflow, events, CD, and otherwise. There are tons of CNCF projects. The reality is you have to pick some, and I think we picked winners. We partner with a lot of GitOps practitioners, so folks from Amazon and Red Hat and otherwise. We've had some input into the GitOps standard. We participated in the GitOps engine back before it was even announced in the open source. So we have a lot of skin and pounds of flesh in this game, and we are so excited to be in the game versus being a spectator. We'll talk about some of the cool things we've employed and shed light on where we're headed, right? Because there is no start and end to a journey. The journey is the journey, and you always stay on it. So BlackRock as a firm, we've always pushed the boundaries of innovation in our almost 30 years of existence. And as a large fintech, we deliver asset management capabilities to our clients through investment and risk management platforms. Investment and risk management is something that mutates over time. investment and risk strategies change over time. So as a large enterprise, we have to constantly keep up with that change, and not just keep up with it, but be proactive and stay ahead of it. And I think that's what has made BlackRock the firm it is today. So what is Aladdin? Aladdin is essentially our investment and risk management technology. If you go to the next slide, please, Ryan. And it's delivered as a platform as a service to our clients using a centralized source of data, and where Aladdin informs our investment decisions, or our clients' investment decisions, and effective risk management, trading, and we do it at very, very large scale. Cloud native is something that, you know, in the mid 2010s we didn't stumble across, but we're always looking to be proactive, always looking to push, right? How can we deliver better for our clients so they can deliver better for their contemporaries and constituents? So cloud native, right? What is cloud native? We stumbled upon it, we embraced it, we looked at it for testing, and we really saw the potential in how we could take what got us here to also get us there, right? Because what gets you here never gets you there. The lessons in the journey along the way help inform how you get to the next step. If you go to the next slide, please, Ryan. So speaking of journeys, right? I think everybody's seen this this fun trail map. Every journey has a beginning, and our cloud native journey started with a bunch of kind of skunk work, like-minded people just kind of talking about this and creating an organic growth within the firm. This cloud native thing is massive, though. If you look at this, it kind of reminds me of the Oregon Trail. There's a lot of options here. There's dragons, and pioneers on the way to Oregon didn't encounter dragons, but like the Oregon Trail and even the 1883 spinoff that Yellowstone has done, for all the Yellowstone fans out there, the journey is possible, but it requires hard work, dedication, the right people, and adopting the right pattern practices and conventions, and building great open source partnerships. It's not all about the technology. Sure, you know, BlackRock has broken a wagon wheel or two, to use my corny cliche, but the journey has value. Breaking those wagon wheels has value. We've learned a ton of lessons, some tougher than others. Those lessons and what we've taught ourselves and pushed down and taught to others has started to spread and grow very, very organically, like a wildfire. That value is even greater than the initial lessons. What's more, being members of the open source community, being huge advocates and community members of the CNCF, we get to stand on the shoulders of giants who have learned these lessons already, who can help empower us to do better by showing us where there's a dragon around a rock or a corner, right? Like, don't go there, go here. It gives us a map and options of technologies where we don't have to write it all ourselves. We don't have to do the proprietary thing every single time in 2020 plus, right? I'll say 2020 plus. Cloud native is huge. Cloud native is more about more than just technology. And so I want to talk to you a little bit about cloud native in general. So next slide, please, Ryan. And as part of our cloud transformation and evolution, we as a firm quickly realized the power of a cloud native approach to development. And ironically, we quickly landed on containers and Kubernetes as a way to abstract infrastructure concerns and challenges from the application tier and future-proof our platform with portability for any cloud. That last sentence is very important. Portability for any cloud. Cloud native is a way to, done well, done right, and done consistently with the right like-minded folks and full support, it gives you the ability to create a portable platform that can be run anywhere. And as you can see, Joe Beda, giant, we absolutely love reading anything he publishes. His quote here is really, really powerful, right? It's about the people, the culture, the technology, the programs and processes we put in place to make this successful. It just doesn't happen by saying cloud native. It just doesn't happen by saying containers, right? So we obviously know that the public cloud providers have a huge impact on cloud native. However, the cloud native development is appropriate for any cloud, public or private. And cloud native is more about applications and how they're created and deployed, not where they're deployed. And in my view, good cloud native hygiene delivers the promise of portability and reduces the supply chain risk for your firm, so that enterprise decisions that happen outside of your scope of influence, you future-proofed your platform for those decisions. Next slide, please. To quickly go through some of our cloud native journey, right? Mid 2010s, we kind of adopted containers, whether it was through development, repeatable environments locally. We quickly moved into like experimenting with Mesos, and then Kubernetes 1.0 was released into a lab context. 2017, 2018, we had a case study. We partnered with Red Hat and OpenShift, and we're able to scale Kubernetes greater than we were able to do when we first looked at v1.0 and Mesos, or orchestration, that is, but quickly doubling down on the Kubernetes investment. We partnered with Intuit and a few other open source contributors and contemporaries to open source Argo events. We needed an eventing framework for our data science and machine learning systems that we were building, but we wanted to follow a known spec, not a proprietary one. So we adopted the cloud event spec from the CNCF that was in Sandbox at the time, and built Argo events and donated it to the Argo project. 2019, I spoke about GitOps a little bit earlier, and we'll go into more detail later. Ryan will specifically, but GitOps for the win. It's been a huge enabler. And then from 2020 till now, we learned that there are some bespoke parts of BlackRock where we needed to use a platform, Kubernetes, cloud native, to build a platform, our Aladdin Kubernetes platform. And 2022 and beyond, more AKP, more adoption, and more cloud native maturity for our firm as we go through this digital and cloud transformation.
Hey, Mike, real quick, if you don't mind me stepping in, sorry to interrupt. Alejandro, did you have a question? The line is open for you, sir. No, he got scared, he left. Okay. Feel free to put the questions in the Q&A, and or you can step up and ask a question. We got the lines open for just about everybody. Okay, Mike.
All right, Ryan, I think it's on to you now, man.
All right. Well, thanks, Mike, for taking us through and explaining why Kubernetes was rapidly becoming important to us and how it's solving, some of our business use cases. I'm going to cover where we started and how we got to where we were before aggressively leaning into open source, GitOps, and some of the other best practices defined by the community. Since BlackRock is a highly regulated financial firm, in some cases, it was easier to build than to go through the process of onboarding an external product. We also have a lot of unique use cases, which didn't always align with some of the roadmaps defined on some of these technologies. So BlackRock created homegrown proprietary software. We built everything from release systems, messaging queues, tool chains, to orchestration systems. I always like to explain a little bit about our orchestration system because it's near and dear to me, but hopefully some of you will get a quick little chuckle out of it. We call our orchestration system MI6 server and SAM. SAM can stand for one of two things: secret agent man or server agent manager, depending on who you ask. And then MI6 server is managing all the secret agent men, orchestrating their binaries. They watch over the double O's. And believe it or not, our orchestration system has a lot of similarities with Kubernetes, though nowhere near as feature rich or robust. It is currently managing 14,000 applications across 19,000 hosts, running in 200 environments. But back to Kubernetes. So as we started that OpenShift journey that Mike was talking about, we still had to abide by our release policies. Again, we're a highly regulated financial firm that's regularly audited. So teams still had to get approvals for releases. Additionally, our homegrown release system didn't understand Kubernetes. So this meant the ops team had to handle any privileged tasks, like deploying to a production cluster. Our developers ended up creating shell scripts, which ended up basically being wrappers around Helm commands to imperatively deploy their microservices. And as I'm sure a lot of you can guess, this process wasn't scaling, even with less than 10 production clusters. As we were planning out our next steps, we formed a laundry list of requirements, a delivery system, a messaging system that worked in and outside of Kubernetes, telemetry, top to bottom, and everything in between. Disaster recovery in the cloud native way that cut against how we do DR for Aladdin currently. A highly available registry. Doesn't matter how many clusters you have if you can't pull an image. Policy management, everything from information security to BlackRock's policies that, again, we are audited against. All these requirements we figured out on the bare metal side and have a solid solution for, but our bare metal solutions didn't translate as nicely to the cloud native side. To meet some of these requirements, like Mike said, we started standing on the shoulders of giants and embracing open source. These weren't just our problems. They weren't just unique to BlackRock. As we started adopting more open source, we were able to start adding add-ons without any upfront capital investment. We could do very deep POCs and POVs and see what worked for us. Next, let's go over some of the open source technologies that make up our platform. Over to you, Mike. I think you're on mute though.
One of my other roles at BlackRock, thank you, Ryan, is I run our internal OSPO, Open Source Program Office. And we, as Ryan alluded to, all of our problems are not just BlackRock problems, they're common problems. Other people have solved these problems. Standing on the shoulders of giants is a pillar of open source. Community is another pillar. One of the other pillars is all easy problems and some complex ones have been solved. So as we started to create our Kubernetes cake, right? Once you start making a recipe, you need a binder, you need other ingredients. We started looking for what those were because we knew that just deciding on containers and Kubernetes didn't get us there. Kubernetes is an innovation that is possible because of the container innovation. And we knew if we didn't have a good container registry story, why would we talk about Kubernetes? So Harbor, a great open source project, has given us the ability to have a platform agnostic way of describing our registry. Other ones in this picture, Argo for all the things that the Argo project provides, ArgoCD included, AquaSec for runtime enforcement and for scan on write and for scanning our Azure DevOps pipelines. Kept, Helm, Customize, those should all be pretty familiar to everybody that's been either flirting with or been in cloud native for a bit. Grafana and Prometheus, right? If you don't know what you're doing and how it's doing and how the adoption is, it's hard to know how to do it better, right? So telemetry and observability are key to any success. Console, service mesh, security by default, encryption in transit, really, really important. Highly regulated company, open policy agent, aggregating all of our metrics and logs, Splunk, Vault for secrets, again, highly regulated company. Had we had to build all these things ourselves, which is what got us to here versus what's going to get us there, instead we embraced, some of these are not just open source, but also vendors, but also adopting the open source that would help us take it to the next level. And we didn't have to solve 100% of the problem. We could just solve the 10%. Next slide, please. And I'll quickly go over Harbor. It's one of my favorite projects just because it gives us the ability to solve the container registry problem without introducing more supply chain risk. We do introduce some operational risk, if you will, but we started this as technologists. We're still technologists. So maintaining, updating software and operating software does not scare us, right? So Harbor is an OCI v2 compliant, the Docker v2 spec. So we can store Helm charts, images, and artifacts in that OCI v2 compliant spec. That includes things like OPA policies and so on. We had the ability to integrate image scanners. AquaSec is one of our vendor products, but also Trivia out of the box was giving us a ton of lift before we went the AquaSec route all in. Telemetry. The Go Harbor chart gives us a ton of telemetry out of the box with its exporter about projects, quotas, and everything there, but also more so how the registry, the job services, and the core features of Harbor are performing. This isn't something I can get from Quay, Docker, or any of the vendor cloud providers very easily, and will typically cost more money. Obviously, this cost is time, human capital, but we do own our own destiny, and it's been really valuable to date. In addition to some of the other features that Harbor has, it's advanced replication features where it can target any of the vendor cloud providers, other harbors, and some other more sophisticated patterns like leveraging a S3 bucket, if you will, for backend storage. Chart Museum, which I think is something that's going to go away because of the OCI v2, but again, we have Chart Museum support for our Helm charts. And going back to what I had said before, it's multi-cloud, multi-tenant. We're not predicated on a vendor cloud provider being available. It's predicated on if we can run Kubernetes, we can run our container registry solution. And so right now we have many, this image is a little out of date, but we have many primary and read replicas on premise in our own BlackRock data centers that replicate out to our vendor cloud provider, Azure, into ACRs.
Hey, Mike, can I jump in real quick with a question from Venkat?
Yeah, absolutely.
If that's cool. He said, how do you manage the steep learning curve and this entire journey? That's a good question.
Deliberately. It's not free. You've got to go. There is, if you think about that Joe Beda quote from before, it's not just technology and it's not just process, it's people and culture. And in people and culture, if we're not investing in our people and culture with training, patterns, practice, and convention, enterprise architecture that is pushed down through our, whether it's platform services or application development teams, without that investment, this isn't for free. And to be completely frank, like Kubernetes is wrought with complexity and abstractions and leaky sometimes abstractions. So there is a little bit of a higher bar for a cloud native developer, and investing via training and investing via relationships and mentorships. That one BlackRock mantra, again, it's very real.
Yeah, and just to add on to that, BlackRock offers us, it's called the TLC, a Technology Learning Community or something like that. Don't quote me on the abbreviation, but they give us resources to be able to attend conferences, get additional learning, have a Pluralsight account, have a O'Reilly Books account, so we can foster that learning and do it. I know that's how I personally did a lot of it. I got the CCAD and did a lot of reading. And, I think ArgoCD folks, Alex, Jesse, and a few others have a book on O'Reilly called GitOps and Kubernetes. So shout out to them.
Yeah.
Also engaging in like Linux Foundation, right? The Linux Foundation gives us the opportunity to get training out of the Linux Foundation training for things like CCAD and the operators. And I know there's a new one that was announced at the last KubeCon. The name has slipped my mind, but again, right, like not just leveraging the technology, but embracing the community and becoming part. The breadth of resources are mass, and better part is there are a lot of very human people ready to help you, whether it's internal at BlackRock or external in the community, like yourself, Josh.
Yes. How about Ragesh? Did you have a question? Take one more. And then we have Hong, maybe take a look at that question in the Q&A box. And Ragesh, going once, going twice. I put you on mute. Okay, Mike, why don't we keep moving forward and we'll pepper in some questions as we go.
Okay, Ryan, I am passing it back to you.
All right.
Here's my man.
So Kustomize, it is our internal recommendation for first-party applications. But before I go into the why and how we're using it, I'm going to give a very cursory overview. So, please go to the GitHub and the docs. There's a lot in the kubectl cookbook and such that you can really get an in-depth overview of Kustomize. But what is Kustomize? It's another way to manage your configuration using declarative YAML. It uses this concept called patches to overlay configuration on top of a mutable configuration. So an example could be, if I look at this image that isn't super clear, sorry, this replica count.yaml, that's a patch that's increasing or changing the replicas to what looks like 80. and the underlying configuration that that patch is going on top of wouldn't need to be changed. So you can reference external configuration and apply your patches on top of it. That's actually how we deploy our ArgoCD instance. We reference the GitHub resources, and then we apply all of the patches that we may need, like sharding the ArgoCD application controller, for example. There's no templates or DSLs. I think that's a little, a nice to have personally. And it's obviously a CNCF project that is part of Kubernetes and part of kubectl as well. So customize, how is BlackRock using it? One of our main reasons for wanting to support customize was being able to version everything and support this concept that we call wave releases. BlackRock has a lot of clients. Some of our clients enjoy the latest and greatest of the bleeding edge, and other sets of our clients do not want to be broken. So the bleeding edge folks, they might get round one of our applications in the configuration, while the clients that don't want to be broken might get the last round of it. Helps us validate, helps us make sure all of our workflows are working. So if we go through this image, right, this base repo, you could think of that as the immutable configuration that I was talking about. In our base repos, we put our configuration that's going to be, the same across all of the different environments that we release to. So you could think of this as like a deployment manifest, a service account, maybe a service in general. Then we have this concept called the configuration repo. This repo contains all of those patches that I was talking about earlier. It allows us to overlay any environment-specific configuration that we may need. So, a very common example is I might need a different image version in dev versus our production client. I may need more resources in our production client versus our dev cluster. So you can kind of see what this is facilitating. And then finally, we have this concept called a release repo, and everything inside the release repo references a version of the configuration repo. So, if you kind of look here, dev is referencing the head version of the configuration repo. Our prod client 1 is referencing version 3.9.4. And these are all Git tags to reference back. You could use, commit SHAs if you wanted to. And then obviously you can't forget about your source code repo. So this is what's building your artifact, building your image, and that image version needs to be updated as well. So I'm sure a lot of you are looking at this and being like, man, there's a lot of indirection. It's kind of hard to see what's going on. And yeah, it's not wrong. And I think that's one of the challenges that we're currently facing. Another challenge that we just recently was able to get around was, upgrading all these things, right? You see the configuration repo referencing the base repo specific versions, the release repo referencing specific versions of the configuration repo, the image version being inside of all these files. That's a lot to update and maintain. And we recently have been using Renovate to help us keep everything up to date, everything from our base image layer to our internal images that need to be updated and our customized configuration. So now let's go over ArgoCD. Oops. So what is ArgoCD? ArgoCD is a GitOps continuous delivery tool. It takes Kubernetes manifests and deploys them into your Kubernetes clusters in an automated fashion. It's built on Kubernetes primitives. ArgoCD at its core is a Kubernetes controller, and there are a lot of other components alongside of it, but at its core, it's a controller. It also comes with a very nice UI. It's templating agnostic, meaning it can support things like JSON, Customize, which I was just talking about, Helm, and yes, it supports Helm hooks too, raw Kubernetes YAMLs, and it even supports a BYO feature where you could bring your own templating engine. So if you want to use, shell and sed, you could do it if you wanted to. So BlackRock, how are we leveraging ArgoCD? We have a central ArgoCD server that's running in what we call our admin Kubernetes cluster. and it manages all of our target workload clusters. We currently have 2 sharded application controllers. So that's what's doing a lot of the heavy lifting of looking into Git, looking into the cluster, seeing if there's any differences between Git and the cluster, and then reconciling those differences. And we're most likely going to have to add a couple more as we're scaling. And if you kind of, if I just take you through this image here, this tenant config repo is what I was calling our release repo in the customized image. So this contains all of the links back to our versioned configuration repos. And you can kind of see in my app here that, they all have different versions. Before, there was this concept called the application set controller, which is another ArgoCD feature that helps you create ArgoCD configuration that does the releasing of the application. So it takes the content in Git and puts them in the target clusters. We actually built our own controller on top of ArgoCD. The reason why we did that was we have hundreds of Kubernetes clusters. And one of these ArgoCD configurations, called an ArgoCD application, is what defines what version of your application goes into which target cluster. So as you can kind of imagine, if we have 100 clusters and a single application needs to go into all 100 of those clusters, that's 100 ArgoCD applications just for a single application. So as you know, we have thousands of these internal applications that need to go to these hundreds of clusters. That's a lot of files. So we built this custom controller that we are going to migrate off of onto the application set controller, but this custom controller is called the tenant controller. And what it does is it takes a single file that defines some of these ArgoCD configuration, and it creates multiple ArgoCD applications for you. So you could think of it as a ArgoCD application factory. And that's actually exactly what the ArgoCD application sets is doing. So we're looking to migrate to that very, very soon.
Hey, Ryan, if you don't mind, to just step in real quick.
Yeah.
It looks like we have you might have talked about this on a previous slide, but it says, do we scan the image before loading to ARC or deployment? I don't know if that makes sense, but
yeah. So we do a lot of scanning, and I'll talk about some of the areas that we scan in, even though this is kind of, I'm taking Mike's thunder here. So we scan in our build pipelines.
Take it, Thor, take it.
So when we construct an image, we scan it before it even hits our registry. And we have rules and OPA policies or policies right now to say if something can go into our image registry. Additionally, Harbor does scanning. So you might not find a vulnerability when you first build your image, right? Looking at log4j, that's, just blew up all of the Java world for a little bit there. It wasn't found until after, all this stuff was in production. So Harbor continually scans it using, many plugins there. It could be Trivy, it could be Aquasec. It's Aquasec in our case. And will tell us if there's anything vulnerable. And then additionally, Aquasec has some daemon sets and additional features to help scan what is running on your container runtimes on the nodes of the clusters. So we do a lot of scanning there. So to answer your question, we scan it before it goes into Harbor, we scan it before it goes into ACR, and we scan it while it's running in the cluster.
Very cool. Thank you for that explanation. I have one more question. It says, how do you handle disaster recovery or failing over to a secondary cluster without updating a significant number of Kubernetes config?
That's a great question. So right now we use the tenant controller. And what we do is the tenant controller is what is producing these ArgoCD applications. And quick recap, the ArgoCD application is what takes the content in Git and puts it into a cluster. So it knows where in Git it needs to look, and it knows into what cluster it needs to put it. And how we do TR today is typically across regions. So, east to west. And our tenant controller is smart enough to realize whenever we're doing a DR, we update a file in Git, a single file, a single line, and that gets immediately synced out to our admin cluster. And what that changes is it's updating the primary cluster URL. So if the primary cluster is west and we need to DR to the east for whatever reason, we update that Kubernetes URL, it gets synced out, And then the tenant controller goes and it updates all of the ArgoCD applications that it needs to say you were in West and now you need to go to East. And then ArgoCD kicks in and does its thing. And it says, hey, East cluster, do you have this application that I know is supposed to be there? And if the answer is no, it deploys it from Git into the target cluster. I want to just say, we're looking at using the application sets as well to be able to facilitate some of this. Instead of changing a file in Git, we should be able to change some secrets that are produced by ArgoCD to help facilitate this in a different way.
Awesome. Mike, do you have anything
Josh,
to add to that?
Yeah, I was going to add on and just say like this is why some of our vendor cloud provider partners, this is why they're great, right? The promise of the cloud is the promise of elasticity and durability. Some of the ways that we've done this to date, we potentially have opportunities to maybe do this different in the future. Where currently, typically in data centers, right, where the corporations manage their own data centers, availability zones are predicated on racks and uninterrupted power supplies and network segmentation within your data center, right? But in the vendor provided cloud, we actually get availability zones that span physical regions or physical locations within a region, right? So within our primary partner, Microsoft Azure, availability zones are in different zip codes. That's great, especially given that Kubernetes can be deployed in a way to where its nodes are deployed with availability zone durability, right? So if one zip code location goes down, we still have the other zip code up presumably, and it depends on how many availability zones are within the region, obviously, but it does give us some opportunity and some things to think about on how we do disaster recovery, and is the cross-region ingress and egress something we need to do as we do more of this cloud transition, as we grow and mature more in the cloud. So the beauty of the cloud is it's full of opportunity, and this is one primary one I think that will be probably entertaining in the near term to see where we can get some additional lift, reduce some costs, but also have greater scale and provide for our clients, which I think is the primary goal.
Awesome question. Keep the questions coming. You can put it in the Q&A box. Yeah, and we'll keep moving forward.
Yeah, please, if anyone sees anything here and they're like, man, we could do this better, I would love to hear your all's opinion, whether it be the Q&A here or an email or what have you. I'm always looking, we all are always looking to how we can improve. So having some fresh eyes would be great.
Yeah, feedback is valuable because it's feedback regardless of the context. So by all means, whether it's here or after the fact, please send us any feedback, good, bad, or constructive.
Great, and I'll share your profiles, LinkedIn, if that's okay with you, and I'll put it in the chat for everybody to connect with you. Okay, great, cool.
Awesome. All right, so we talked about Kustomize, we talked about ArgoCD. I'm jumping back to another way to handle configuration, and that's Helm. Like I said before, we recommend Kustomize for our first-party applications. We don't force our developers to use any tool, though. We've seen a lot of benefits with Kustomize, so that's why it's our recommendation. But there's also Helm. Helm we typically use for our third-party dependencies, and I'll explain why. So, what is Helm? You can think of Helm as like a Yum, a Homebrew, an APT, a package manager. Helm helps you install packages. These packages consist of Kubernetes manifests, templates, and life cycle hooks. And typically they're called charts.
Ryan,
allows you.
Can you say that 5 times real fast?
I had trouble saying it once.
Just kidding.
So Helm lets you be able to deploy things. It lets you roll back, install very easily. So this Helm package comes with what the maintainer of the chart says is good defaults, and then you're able to customize that configuration any way you would like using templates, typically built on Go templates as well. Helm charts are also OCI compliant. So circling back to Harbor, you can push them into Harbor registries, and that's what we do. So how do we use Helm? We use it to install a lot of our third-party applications. Some of our first-party applications are using Helm to deploy. If you remember from when I was talking 30 minutes ago, we used Helm originally. and that was to help us to deploy. But now that we have ArgoCD, we don't need it as much. So we deploy 30 third-party applications like Console, Prometheus, Vault, Harbor, and what you see on the screen there, plus some more. So we use all this open source technology. We did all these things. We got customized referencing, 3 different versions all over the place. We have ArgoCD doing all this stuff. How did we get there? We built AKP, the Aladdin Kubernetes platform. Sometimes it's called a Kubernetes platform because it outgrew just supporting Aladdin, and now it's supporting a lot of BlackRock's products as well. I always like to throw out this quote, Phil Carlton, there's 2 things hard in computer science, cache and validation and naming things, and we still struggle with naming things to this day. So just taking you all through the image here, we have the common API, right? That's Kubernetes. We have PKS, TKGI, TKG from VMware that we run, and OpenShift for on-prem clusters. And we obviously have the classic set of cloud providers as well, though we lean pretty heavily into Azure. The next layer is the core platform. So this is all of our things to help developers ship code and not containers. It abstracts away Kubernetes and jurisdiction differences. I might have a different storage class provider on TKGI than I would for Azure. And it also allows an extended interface that developers can build upon. And then finally, the highest level there are segments. These are our business applications, some of which make up Aladdin and others which make up other BlackRock products. And all of this, just to kind of recap, was done declaratively and deployed using ArgoCD. Being declarative allowed us to deploy all of the core platform and business segments in a versioned and continuously reconciled way, where we went from those 10 clusters that we were struggling to scale with to now AKP supports over 170 clusters. So I want to talk a little bit about how we went from, barely having 10 clusters to how we now have, a little bit under 200 if you look at the Grafana dashboard there. So, if you were listening closely, we had 10 and now we have over 170, and I'm pretty impressed by that metric. So, how did we do it? We created an idempotent workflow that gets triggered via a remote procedural call every time a cluster is created. Everything is done through Git pull requests in ArgoCD. So this workflow will pretty much just interact with Git, create and merge PRs, and then ArgoCD will take action. So let's talk about some of these. So first step is to create the cluster. We have CI pipelines that create the clusters, which is done in typically Terraform. The next step is to register that cluster with ArgoCD. So we run a job that interacts with the cloud providers or our jurisdiction specific login. So we'll go and get a kube config. It will then talk to ArgoCD using the ArgoCD CLI, and ArgoCD will go in and create the necessary service account on behalf of itself into the target cluster. So that way, ArgoCD running in a cluster outside of the target cluster can then communicate back in. From there, we apply cluster configuration. So we start this by using kept packages and customized bases. The kept packages and customized bases contain, this cluster configuration. So namespaces, service accounts, controllers, and other cluster level resources that need to be present before our business applications get applied.
Hey, Brian, I'm going to interject, and if it pleases the court, I'm going to lead the witness just a touch and give our partners on the phone from Upbound and Crossplane some support. That first box, creating clusters with Terraform, if the vendor cloud provider or the hybrid cloud Kubernetes distribution has a API provider for Crossplane, is Crossplane able to do that same virtual infrastructure release?
I believe it can, and we could do it declaratively, put those configurations in Git, and probably do the whole workflow via ArgoCD deploying those customize specific configurations to the cluster in Crossplane, taking the necessary actions.
Service accounts too?
I would imagine so. I'm not sure about that one, but I would guess so.
Kind of leading Daniel to witness now. Daniel, service accounts, service providers, given the different vendor clouds?
Absolutely. As long as a cloud provider offers an API, you can access it via Crossplane in your Kubernetes cluster. I'd also mention that even things that are not cloud provider APIs can be managed via Crossplane providers. Great example of that is you can actually deploy Helm charts via our provider Helm and that sort of thing. So even if folks are running Kubernetes on-prem or manually setting up with kubadmin or something like that, those can all be declaratively managed, and abstractions can be created on top of those with Crossplane.
That's really interesting. So if I had the ability to containerize a process, and that process was bespoke and proprietary to BlackRock, I could use Kubernetes lifecycle and resiliency factors to manage that non-Kubernetes workflow?
Yeah, that's exactly correct. And, it typically caters, to be honest, to things that can be managed declaratively. There are imperative actions, such as things like a database backup or something like that, that you want to happen in response to a non-create, update, delete event. Maybe it's on a cron schedule or something like that. But anything that you could containerize, any sort of logic that then you can then represent as a managed resource, which is essentially a sparkling custom resource definition in Crossplane land. You can then offer that via provider. And importantly, a really important part of the Crossplane aspect of that is start to build a platform on top of those granular APIs that you present.
I love it. And I want to tell everybody that's in here, this was not planned. I am just such a big fan of Crossplane, and Daniel wasn't in at the very beginning. And I just wanted to make sure that I got to hear from him and whether BlackRock uses it, I think as an open source advocate, as our OSPO lead at BlackRock, this is one of the highest quality open source projects out there. I put it on the same pedestal as I would put Argo and a bunch of the other ones we've talked about today. So Daniel, again, thank you for letting me lead the witness. I do think that information was germane to the conversation because a lot of this skilling up is learning new tools. And if you can have a consistent tool chain that can do it all the way from virtual infrastructure to application delivery, that means that your training tail is a little bit narrower. It's not as wide, and you don't have to learn as many tools.
Absolutely. And if folks stick around at the end, we'll do a Crossplane project update. And also wanted to say this architecture y'all built out at BlackRock, really strong. So it's cool to see how you are using the different components together. We obviously think from a Crossplane perspective that standardizing on the Kubernetes API means that you get a lot of benefits of being able to use projects really well together. We specifically like to encourage folks to use GitOps via Argo with Crossplane, right, to manage their infrastructure. So really cool how you all have pieced all these different projects together.
Cheers. Thanks for that, man.
Yeah.
Thank you. Ryan, go ahead.
Yeah, no, that was great. So I just want to do a quick little recap, just so we all remember where we were. We created a cluster. We registered it with ArgoCD via a job, and we are applying our cluster configuration via kept packages and customized bases. And I just want to give another customized plug and why we're using customized bases here as well is it allows us to do these overlays. So our customized bases typically are grouped in such a way where all the configuration in one of these remote bases goes together. And as we reference all these bases, like we might have an AKS base versus a TKGI base, because the configuration might vary a little. And what we do there is then if we need to patch that configuration, we can. So, another classic example of us patching something is in the base, maybe the namespace quota is 10 CPUs, but then, after it gets through dev and we start handling all these requests from, much more users than in our dev environment, we need to bump that quota up a little bit just to support the load. So, all the pods and the resources in that quota can use more CPU. Next, we apply our platform components. So, platform components, as we look back to that other slide, service mesh, telemetry stack, security scanners, AquaSec, external DNS, everything that allows our developers to start just using the clusters. And then these last two boxes that are a different shade of gray, maybe grayish blue, here are things that we would like to have. So our next step is we want to start deploying our business services. We really want to use the application set controller to be able to help facilitate that using the ArgoCD cluster secrets. And then we want to be able to run smoke tests after those business services are deployed. And we also want to use ArgoCD, what are they called? Hooks, to be able to just, once the application is synced and everything is good to go, to kick off a bunch of tests to make sure that the environment is up and ready to be validated by our QA team and such. And I always like
smoke tests are the gateway drug, right, Ryan? We want to get to like synthetic testing and much more advanced, complex testing, where, again, going back to the Kubernetes, learning Kubernetes and learning the stanzas and everything you need to know, gives us the ability to bifurcate what is our application and business logic from synthetic testing of said logic, which is super powerful.
That's right. And just the last little Grafana dashboard here, 174 clusters, a little under 2,000 applications, where an application in this sense is an ArgoCD application. So that is a Git repo to a target cluster. And it's watching about 103 repositories, though I bet you that doesn't count all the customized remote bases that we have.
Yeah.
And with that, I want to do a quick demo.
Drum roll, please.
I thankfully recorded it because with my internet connection coupled with the VPN and such, you never know what you're going to get. So if everyone can see my screen, I'm going to kick it off and I will talk you through what we're looking at and what's going to be displayed.
Just maybe before you jump into that, so what are you going to show? Just kind of.
Yeah, sure. I'm going to show how you can go from an application here, which is GitOps demo, make a very simple configuration change, and without doing anything other than merging a PR, see that configuration change referenced in the cluster deployed without doing anything other than your typical developer workflow of creating a PR and getting it merged. So what you're looking at here is the ArgoCD UI. If I were to click this applications button, which I can obviously, it would show all the applications that are deployed via ArgoCD. So we were looking at a very specific instance, the GitOps demo instance. I'm going to take you through what some of these buttons do and what they're telling us, and show you how the simple configuration change can propagate out. So looking at the app detail here, you can see where the application is deployed, the namespace, the URL of where it's getting deployed from. I'm going to go back a little bit there, hopefully get rid of this thing down here too. So you can see where it's deployed to, the Git URL, the target revision. So that's the main branch. The path inside of the Git repository. So inside of GitOps demo, there's a folder called deployment. You can see some sync options here, and you can even see the image that's getting deployed, just a pretty classic Nginx image. Next, we can look at the history of what was deployed. You can see the commit SHA that deployed it, all of the iterations of when it tried to deploy. So you'll see, 0 minutes to deploy. So what that's telling me is I know that the same revision was probably already there when ArgoCD went to sync this. And all it did was say, hey, Git, what do you have? Hey, cluster, what do you have? Oh, they are the same thing. I don't need to do anything. I'm going to keep on going. So you can see, who authored the PR and some metadata about the PR as well. So this is a config map. This is actually what's going to change in the PR. We're going to change a URL down here, specifically this image, an actual image like a picture, to something else. And now I'm going to show you what that image is. So this is our CEO thinking about cloud native. So what I'm doing here,
Ryan.
I hope so. So what we're doing here is we're changing the image to happy. And you can see in our Git repo, we have, the happy image. You can see the deployment folder, which I talked about before. You can also see we're on the main branch, which is what ArgoCD is watching. So I'm going to create a PR here. I'm going to create a new branch to make my changes. Good developer workflow. I'm going to create the PR. Hopefully I would have a build linting these manifests that I just changed to make sure they're valid and they're not going to do anything bad. Hopefully I have some OPA policies in my CI pipeline shifting left to make sure what I'm trying to deploy can actually be deployed. I wouldn't want a developer to try to give themselves a cluster role binding that gives them admin access to the entire cluster. So we can lint against those things. Should also probably link a work item so I know what's being changed. But I'm going to approve
That
it. and
hopefully
merge it
is
anyways.
rhetorical, right, Ryan? Hopefully we have
It
open
absolutely
policies.
is rhetorical.
Okay, good job.
All right, so it merged. What we're going to look at next is the commit SHA, so we know, what actually was released or what was changed here. So there it is, that ACA, and you can see my change obviously using Git. One thing I want to call out is a rollback can be as simple as using the Git UI and doing a Git revert. But here are my changes. They all look good. Going to go to ArgoCD now. I'm going to poke ArgoCD here. You can set up webhooks so it gets triggered. Webhooks aren't set up on this instance. So I'm going to poke it here. I'm going to tell it to go check Git to see if the commit SHA that it's watching changed at all. And what should happen, and I know will happen, is it's going to notice that it went from commit SHA something to 9F6 to ACA. And then ArgoCD is going to take the changes that I made and deploy them to the cluster. Oh, it noticed.
Got a question, Ryan. Just when you're ready. Sorry, we have a question.
Yeah, hit me.
So Venkat says, what performance indicators improvement that you derived through this entire adoption? Does that make sense?
Is that what is our opportunity to improve based on performance indicators?
Venkat, do you want to expound on that real quick?
Yes. Yeah. That's what exactly. Performance indicators as well as the business drivers, the business performance improvement, something of that nature that fuel the improvement in Aladdin platform.
So Ryan, I'm going to let you take what we've already been talking to Hong and other Argo and ArgoCD contributors about scaling, sharding, and so on. But Venkat, just from an Aladdin perspective, right? We need more humans training the autonomous and robotic processes that roll out our system. Innate in that is higher velocity, more checks, more autonomous checks like open policy agent, where we can check whether it's shifted as far left as we want and as far right as we want in the software delivery pipeline. We aren't removing humans from the process. We're just getting those humans to program more autonomous processes. And in that, we have fewer manual steps and they're in higher velocity. And we have a ton more wood to chop to increase that velocity. As a highly regulated firm, there are just some things we will never be able to do completely straight through. But I think that we can solve 9/10 of that with more investment in DevOps, more investment in DevSecOps, and plug in the popular word in front of ops. But DevOps and everything that has come from that, GitOps and DevSecOps, the more we invest there as a firm, the more like-minded people, culture, patterns, practices we have built around that, the higher velocity we'll have, the more business value we will there in turn deliver to our clients.
So I want to add to what Mike said. Mike well said. So in the end, it's about the culture change and it's about time saving. So basically what Mike mentioned is more about automation. So Kubernetes is the perfect vehicle because it has this declarative API. So that is a mindset change. Like you don't just provision something, you do some manual thing here and there to maintain your infrastructure. It's declarative, means the YAML is the blueprint. It has everything you need. And then it's making everything can be controlled from the GitOps, means For the infrastructure management, for the DevOps process, it's not different from your development. You go through the same code review, same process to actually manage your infrastructure. You know, when this, like Ryan has this like mindset is when that PR got merged, the result will be that. So you got that confidence by all the automation means you don't need to spend time to go back to check, oh, did I manually do that? Do I have maintain a run book? Do I need to share my run book to my other teammates? You limit all that. You trust the system, everything's automated, you get time back. Then you means higher velocity, you can release more in baby steps. And it's time saving from all the other aspects, like you focus on more on the product development. We see the tremendous like productivity improvement at Intuit also with like 4,000 developers. I think the BlackRock had the similar experience. It's not easy, I would say, for the culture change, but it will worth it in the end.
The journey has value, right? To go back to one of my first slides, it's not easy. It's not a silver bullet, and there's many other cliches. Hong well said. It is very, very deliberate, but if you're disciplined in that deliberate culture change, it yields a tremendous amount on the other end. And higher velocity is just one of those value adds.
That's great. That's great, guys. That's really helpful. Mike or Ryan, wanted to ask you, I think Andrew has a really interesting question. It says, did you evaluate any other technologies against Crossplane? If so, what did you learn? Not sure if you've answered that question or not. But,
I can, because we did some homework recently.
okay.
So we just take the AWS as example, like what's the option on the table. So first one is basically is the CloudFormation. And it's big, it's also complicated, it's slow, and we didn't like it. And also it is not it cannot cross the cloud provider boundary, means if you want to run something on the GKE, you cannot using CloudFormation template. So that's a no. Then we tried to using the CDK a little bit, and we found the CDK in the end is CloudFormation again, so it's slow. And another thing we found is the CDK is not flexible enough for our use cases. It has all this kind of like derived naming convention. Like it will say, hey, this is the VPC name. It will appending something afterwards, making our life much harder because when we want to reuse some component in the CDK, then it's not that flexible. Then the Crossplane came in from mind. It's not perfect. Daniel, I know it's still under a lot of development, getting much better, but we see it's very promising and very flexible because we are the believer of the Kubernetes API. I mean, we are believing the YAML. How you getting the YAML is a different story. So we see the Crossplane definitely is in the sweet spot. Is you got a whole set of the YAML delivered by the ArgoCD declaratively, and it will resolve the dependency property. Means, hey, it will create the IAM role first, then it will passing the IAM role name to your like EKS cluster. Then the EKS cluster provided, then you will have the EKS cluster ARN referenced by the other thing. So basically, you have this kind of like hierarchical thing, and it will provision the same like a tree grow, like from the bottom up. And eventually, you got everything. It will take a little bit time there, but we feel it kind of like, to our expectation, it can support multiple cloud provider for sure, which we already see. And then you have Kubernetes API native there, so you can deliver like deploy things in the ArgoCD naturally. So it means you can do the code review, you can do the PR, you can sync it. That kind of like also the reason we didn't pick the Terraform, because that is not Kubernetes native. And we got more comfortable with Kubernetes native stuff at this stage. But not means Terraform is not great. I think a lot of people still use it. It's working great. I believe it maybe even have the cross-plane integration. I'm not sure. Daniel can give us the update later. That's
he's chomping at the bit. I can see him just ready to go.
But that's our experience about the cross-plane especially for the infrastructure provisioning. I think it's working pretty good.
That's really good. And that's really informational. I think a lot of people aren't aware of that, Hong. So thank you for sharing that. That sounds like that could be a great blog post, by the way. I don't know, or maybe Daniel, you have a blog post in you for that one. We could share that with the community. Any thoughts on that?
Oh yeah, I'll grab some links for folks after we wrap this up.
Got it. Got it. So Ryan, do you want to finish up with what you're demonstrating there?
Yeah. So real quick, we made that change in Git. The Git change was recognized by ArgoCD by me giving it a little poke, and we already see it synced out. We can just quickly watch it again sync. It's gonna flash yellow then green. That means it synced it, and now we should see a different image whenever we refresh this URL. We're gonna check the commit too. It's that ACA that we looked at before. And just proofs in the pudding, there's the new URL pointing to the image. And then finally, we're gonna cache refresh the image. And there it is. Happy that we embarked on the cloud native journey. So that is all I got. I think I'm gonna hand it off back to Hong, and then we can get an update from Crossplane.
Yeah, thank you. I think everyone already know Daniel right now. So Daniel is a senior software engineer at Upperbound, and he's primarily working on the open source Crossplane project. And without further ado, I think Daniel, let's give us the project update. We are all looking forward to it.
Awesome. Well, I've totally enjoyed the presentation thus far. I'm definitely glad I got to see that. And as Hong said, I'm going to give just kind of a fairly brief, I think 10-minute project update here. I don't know how familiar everyone on the call is with Crossplane, so we're going to start off with a quick overview, which may look actually a little bit different from some things y'all have seen with Crossplane in the past. But I'm going to go ahead and start going through this. All right, so this is focused on where we're going in 2022, and also looking a little bit about what we've done in the previous quarters as well. So just starting off, if you're not familiar with Crossplane, essentially what it does at the base level is it allows you to provision infrastructure as Kubernetes objects, right? So you essentially have a provider model, which you're probably mostly familiar with from other infrastructure as code tools that allow you to plug in, say, the AWS APIs and be able to deploy, an RDS instance alongside your deployment or service or something like that. So folks usually grasp that part pretty quickly, but we actually see that as kind of just the most rudimentary usage of Crossplane there. And what's illustrated on this slide, right, is that the APIs across these cloud providers, though they may all offer, MySQL instances and some sort of container runtime as a service, they're pretty heterogeneous, right? And they offer differing levels of abstraction. So you as an organization, we like to generally say, want to offer a control plane. And a nice comparison we like to make for folks in that is kind of like a build your own Heroku, right? You should have your APIs for your organization, but not have to actually build out your own cloud provider, right? So essentially what this looks like is a layer that sits on top of it. And we believe from a Crossplane perspective that layer should be integrated with the Kubernetes API. So then what you actually present to your developers or as a platform team, right, is your own sort of APIs at varying levels of abstraction. And there's lots of tooling to build those in Crossplane that it runs on top of your control plane, but is backed by Kubernetes and Crossplane. And to be able to bring these granular APIs that the cloud providers offer, we have something called provider packages. So you basically install a provider, right? And you get the AWS APIs present. And then to be able to build your higher level abstractions, you install what are called configuration packages. And they use a mechanism called composition, which is exactly what it sounds. It composes these lower level APIs that cloud providers offer into higher level abstractions. So you may offer a database type to your developers that they could put in their Helm charts or their customized configs. And that could be backed by RDS on AWS, Cloud SQL on GCP, and you can actually present the same API into both of those implementations. And that's really just the simplest example, right? You can really get some larger abstractions going. One that we see folks use a lot, which we kind of touched on a little bit earlier when the folks from BlackRock were asking some questions, is being able to spin up Kubernetes clusters themselves. If you've ever brought up an EKS cluster, you know there's a fair amount of overhead doing that and a lot of different AWS components involved in getting that up. Crossplane can kind of give you a cluster abstraction that will declaratively deploy all of those components and can even compose other things that would go into that cluster. I mentioned provider Helm before. We see a lot of folks using Crossplane to do something like spin up a cluster with ArgoCD installed to it, right? But that's just a single API that you interact with, and those granular types have been composed into a higher level abstraction. So when we look at kind of the last few months of Crossplane and going into the future, I like to say our theme is maturity and flexibility for any enterprise use case. So Crossplane has kind of reached a level of stability. Over a year ago, we reached our 1.0 version. We've become an incubating project in the CNCF. So we've reached some real confidence from our users in terms of the components that we offer. And so what we're doing now is taking that to the next level to say that all the folks that use Upbound or use Crossplane are able to actually use it for all of their enterprise use cases and building in some flexibility to deviate from the default path there. So looking at where we've been in the last few months, we've reached robust API coverage. So our various providers, we have kind of two different flavors of providers. Some that have been hand-rolled, which essentially means that we built out all of the controllers to be able to manage things like RDS and EC2 instances or GKE clusters, et cetera. One of the things we've done to accelerate that is reuse the logic that Terraform providers have built inside of them, right? So we're not actually running Terraform per se, but reusing those open source modules to be able to get full API coverage. Those are totally open source. But what this allows you to do is anything that has a Terraform provider today, you can generate a Crossplane provider from that and get very nearly full API coverage, or at least everything that the Crossplane provider or the Terraform provider offers to you as well. Which means that with something like provider AWS, we now have support for 763 APIs, which is a vast swath of the AWS API. So it's been really exciting to see that, and that really boosts that kind of like provider level that you then compose. Looking at
mic drop, Daniel, right there. Sorry to interject, but that is awesome. Just quick question on that. Do you have a blog post that related to this, or happy to connect with you offline?
There may be an announcement this week that y'all are getting a preview of
awesome.
in relation
All right,
to that.
Thanks. Carry on. Sorry about that.
Absolutely, absolutely. Another thing is just looking at the core engineering of Crossplane and the providers, and actually looking at upstream Kubernetes as well. What I'm showing here is an issue that we found as a result of being able to get this robust API coverage. Adding a ton of CRDs to the Kubernetes API server actually caused some pretty severe bottlenecks, mostly because the way the Kubernetes API server works is it computes a full open API schema for all the types that are installed. And so adding a bunch of CRDs led that to be recomputed over and over again in quick succession, which is causing issues. So we actually made some fixes upstream to how that works, and also have made adjustments in Crossplane and providers to be able to expose some configurable reconciliation rates, which essentially means you can say something like, I only want you to ping the AWS API every hour. Or maybe if it's a production, critical workload, you say, I want you to check in on the status of this every minute. And exposing that to the users actually means that you can have different configured providers for different environments, right? We see the folks in development have kind of longer intervals in reconciling your infrastructure, and in production, maybe quicker succession.
So Dan, you are getting some rave reviews here with Crossplane. So we say Crossplane looks awesome. That's why I need the recording to review with some associates. Okay, so maybe we have a lead for you, Dan.
Awesome.
We're working on that. We'll follow up with you, by the way. And I'm sorry, I'm gonna mangle your name, so I'm not gonna try. But I have I have these recordings and these questions, so we'll follow up with you.
Awesome. That sounds great. Just looking at some other things that we've done in the past few quarters is formalizing some of our existing concepts. So two of those areas that are really important that folks interact with a lot would be our composition API. This is basically the way that you can define a new type and how the abstract new types fields map to the granular types. So just providing more examples and best patterns for how folks can consume that. And we're actually going to talk about that a little bit more in a minute and for what's coming. And also formalizing our X package specification. So our packages, whether providers or configurations, are OCI images with basically some opinionated YAML inside of them. We kind of took an interesting approach and have been doing this for quite a while. And one of the things that we wanted to be able to do is enable folks to be able to kind of hand build these packages and also extend them, right? If you are a consumer of Crossplane or you even want to create your own Crossplane distribution, we wanted to have a standard way for extensions to be added to these packages that may be specific to a given vendor distribution as we see, folks start to build out more and more conformant Crossplane distributions. So that's definitely really great. And just having more formal specifications around the various APIs we offer is great. Now, looking into where we're going, there are a number of extremely exciting proposals that have been accepted for things that will be added to Crossplane in the near future here. And I want to walk through a couple of them because I think they're going to be of great interest to anyone who's really familiar with Crossplane, because these are things we've talked about for quite a while. So first one here is external secret stores. If you've ever provisioned infrastructure using Crossplane, you're likely aware that the connection secrets to the infrastructure you provision can be written to Kubernetes secrets. And the way that folks consume those is either directly through the secrets. So they have a application that's running, and in the pod, they reference a secret that their database creates. Or they have some system that syncs that to an external store, whether it be Vault or some cloud provider KMS, anything like that. Those are various ways that folks consume them. What we'd like to do is say, you don't have to write Kubernetes secrets. Lots of organizations, especially large enterprises, are not going to want to store sensitive information in Kubernetes secrets. So we have a plugin model that's coming that will allow you to write those connection secrets directly to those external stores. And you can basically configure that based on whichever one you want. And we'll have a set of kind of default stores that are supported, the common ones that you'd expect, like Vault. Another one here, if you've ever used Crossplane, you're likely familiar with cross-resource references. This is a critical part of provisioning infrastructure and also building abstractions on top of it. Essentially, this is, if you create an EKS cluster, you're going to need to be able to reference the subnets it runs in. So you can use Kubernetes object references as opposed to just the names of those subnets. And that's something that's been supported in Crossplane for a while. And you can actually select those objects using label selectors and things like that. Now, right now, all of those references are built in as kind of hard-coded fields, right? So if you have a subnet or a subnet group that you need to specify for an EKS cluster, the CRD literally also has a subnet ref field and a subnet selector field that you can populate to have that subnet field initialized for you by the controller. Now, that's really nice, but there's also, additional use cases where folks want to make arbitrary references where it may not be actually part of the API, but you say, I have a config map over here that has some data in it, which I want to use to populate the subnet name. So generic resource references are going to allow you to reference arbitrary fields on arbitrary objects to be able to populate the fields of the infrastructure you're provisioning. This is also something that should be coming pretty soon in Crossplane. Another one here is observe-only resources. This is also something that's been open for a while. You'll see September 10th, 2020, and we have a pretty good line of sight on this as well. Observe-only resources are for the case that you have existing infrastructure or maybe just some additional infrastructure that is not managed under Crossplane, but needs to be referenced by other things that you're provisioning. This plays really nicely, as you can kind of see with the generic resource references. Observe-only resources basically mean that you can create a Crossplane resource. It will be late initialized by the controller, so you'll get that full status that's represented externally. And then you can start to reference that from infrastructure that Crossplane is managing the cluster, but Crossplane won't take any active steps against this observe only resource. So definitely have some folks that are excited about that. Another one, and this is quite possibly the largest one, is custom composition. Our composition API is fairly expressive. The way it works is you have kind of those abstraction fields, and you use what are called patches in your composition to be able to map those fields to the granular fields on the cloud provider APIs or whatever API you're composing. And that's really nice. We have kind of a DSL for doing that. That being said, as you've seen in the BlackRock presentation today, there are a lot of tools to be able to do kind of config management and that sort of thing. And we want folks to be able to use whatever config management tool they like to do composition or write their own, right? They could write some actual logic to be able to perform those compositions. So essentially, custom compositions will allow you to swap out the composition engines. You can view this kind of like the various interfaces that Kubernetes itself offers for networking or something like that. And so custom composition basically means that you can bring an engine that offers the sorts of transformations that you want. And we anticipate a pretty robust ecosystem of composition engines being introduced. You can obviously continue to use the default composition engine as this comes about as well. Another one, which is in the similar vein, is the provider runtime interface. When you install a provider, you obviously bring all of those types as CRDs, but you also need the controllers that reconcile them. Right now, Crossplane introduces those controllers by creating a Kubernetes deployment, which is typically a great solution because you're already in a Kubernetes cluster. It's a great way to run your controller, and you can configure how that deployment actually gets provisioned. However, there are folks that have additional use cases where they want to run those controllers potentially outside of it. So you can imagine a controller running in a different cluster or as a Knative function or as a cloud run service or something like that, completely external to the service. And what the provider runtime interface offers is a way to, once again, have kind of different engines for deploying those controllers. So you can have full customizability over how to do that. Once again, continuing to use Kubernetes deployments and following that happy path will still be available. So it won't introduce additional complexity unless if you need the flexibility that it offers as well.
Well, Dan, we've got to wrap it up, my friend. This is really fantastic. I'll let you finish your thought, but we'd love to have you come back. So we'll plan something in the next few months and we can do a deep dive with you. But go ahead and finish up and then we'll wrap this up, everybody.
Absolutely. And that's perfect because this is the last slide here. Provider partitioning fits really nicely along with that runtime interface. It allows you to specify different controllers that are reconciling specific infrastructure within your cluster. And with that, I'll go ahead and finish it up. And I would absolutely love to come back again for a deeper dive.
If we can track you down, Daniel. Are you at the office, by the way? It seems like you're at the office.
I am at a meeting, but not at our. We don't have a formal office.
All right, it looks suspicious there. I think there's a fantastic talk. There's definitely a lot of interest in this project, and usually it's one of two things. When people are quiet, it's because they're trying to process this is new to them. And I'm thinking, I wish we would have done a poll, but I think a lot of people are actually quite new to this project. So that's my thinking. Or Dan, they're just bored to tears. So it's usually one of the two.
Well, typically when I present, it's the latter. So
no. It's good stuff. So Mike, Ryan, I want to thank you very much. Dan, thank you for giving us an update. This was fantastic. Hong, thank you for hosting this event. And I just want to share before everybody leaves, we'll show, can you see my screen there? So we have our next event. Maybe Hong, do you want to just tell us what you're going to be talking about here?
Oh yeah, I think we got a good traction on the Argo project. So Argo is actually not just about ArgoCD. So I think for the next week, we will, it's 2 weeks from now. So we'll have a presentation talking about the briefer history of the Argo project, I think from the founding engineer's perspective. So it will be a more like casual conversation, understanding the history about the reasoning, So you will get an answer about why you need to use Argo, because we are solving the practical problem as we adopting the Kubernetes. And also we are giving a very introductory demo about all 4 Argo products. So you will get a feeling about each product. So you can think about it as our Argo 101 conversation with some history background there.
Awesome. Yeah, I highly recommend this event, everyone. This team here is the tip of the spear when it comes to Argo and GitOps in general, the real Argo OGs, as I like to call them. So we'll push that out. Lots of people are asking for the presentation. Mike, Ryan, if you could send us that presentation today, and then we'll include that in the follow-up email tomorrow with the recording. And if there are any other resources, Hong, or anybody that you want me to share, I'm happy to push that out. Dan, you as well, if you want me to include that, we can do that as well. Okay, everybody, I think that's it. Mike, thank you. Ryan, thank you. We'll have you come back. Hope to see you in Valencia, Spain.
Yeah, hope so. Thank you so much for having us.
Yeah, thanks for having us.
Touch base later in the year. We've got an internal project that we're going to be open sourcing soon. Somebody, I'm not sure if he's on the phone, Vaibhav Page, a Argo Events OG is getting ready to open source something. So we'd love to come back and talk about it.
Absolutely. Open invitation anytime, guys. For real. Just let us
everybody.
know. We'll work you in. Take care, everybody. Bye.
Thank you. Thank you.
Thank you, everybody.
Bye.
Mhm.